Hi guys, today's lesson is on equations that have either no solution or an infinite number of solution. So for today we're going to be solving equations, and frequently what's going to happen is it's either impossible to solve, meaning there's no value for x that will work, or anything works. That would be an infinite number of solutions. When this happens, it's called a special case. So we'll talk about that a lot. These are special cases. They don't follow the normal rules of solving equations. So let's go ahead and get started. All right, let's start with no solution examples. It's easy to illustrate a simple equation that's impossible to solve. For instance, if I say x plus 1 equals x plus 2. Well, if you just think about that for a moment and don't start solving it, if we see a number x and we add 1 to it, like we do here on the left side, and then we take that same number x and we add 2 to that number, it doesn't matter what the value of x is, those two sides will never be equal. If x is 0, for instance, the left side is 1 and the right side is 2. That doesn't work. If x is 1, as another example, the left side is 2 and the right side is 3. They're not equal. No matter what numbers I plug in, the right side's always going to be bigger than the left side, because on the right side I'm adding 2, and on the other side I'm just adding 1. So this means it's actually impossible to solve, and we call that no solution when we have that situation. Now, they won't always be this easy to recognize. So I want to show you, if you're solving this algebraically, what it might look like. What we normally do first, before you would subtract 1 or subtract 2 from both sides, we would try to get the x's together. If you don't do that first, get in the habit of dealing with those x's first if they're on both sides. So we're going to subtract an x from both sides. These cancel, and I get 1 equals. That cancels. 2. And since the x's cancel on both sides, that's how we know we have a special case. So you might want to pause it and jot that down. If x cancels on both sides, or whatever your letter is, then it's one of those special cases. It's either no solution or it's all real numbers. So when x cancels out on both sides, it's one of these special cases. Now, the way that you tell if it's no solution or all numbers is you look at what's left. You still have an equation written here, it just doesn't have an x in it. We have 1 equals 2. You look at that and you say, is that a true mathematical sentence? Does 1 equal 2? In this case, no, that's false. That's how we know it's no solution. So if it's a false statement that's left after x cancels out, your answer is no solution. If that would be true, and we'll show some examples in a minute, like 1 equals 1, then that's a true statement. That's the other case. That's when it's all numbers, meaning anything works. So when we have this, this is an example of no solution. Now, there's a couple other terms we use instead of no solution sometimes. So sometimes we'll say no solution. Sometimes we just use a symbol. So you need to write these possible alternate names for no solution down. This symbol right here is like a 0 or an O with a line through it, and that's just the quick symbol. You can use like a shorthand for no solution. Sometimes it's also called the empty set, meaning the set that is the solution is empty. There are no answers. They don't mean the same thing, though. They mean that it's impossible to solve it. Okay, let's do a example of an infinite number of solution. So let's say I have this. X plus 3 equals 3 plus x. This is a clear, simple example of an equation that has an infinite number of solutions. It means that no matter what number I choose to use for x, it will work every time. And this is an easy example to see because I basically have the same thing on both sides of the equal sign. On the left side, I have x plus 3. And since addition is commutative and it doesn't matter the order that I add, 3 plus x on the right side is the same thing. no matter what x is, on the right side I'm adding 3 and on the left side I'm adding 3, so it should still be the same value. So no matter, and we can do a couple examples, like if x is 0, whoops, on both sides, on the left side I have 0 plus 3, and on the right side I have 0 plus 3. If x is 2, on the left side I have 2 plus 3, and on the right side I have 3 plus 2, both 5. That'll work no matter what number you plug in and guess for x. So we call this an infinite number of solutions. And again, just like with no solution, they won't always be this easy to recognize. So you'll start solving them algebraically a lot of times. So I want to show you what that might look like. So like I said earlier, you want to move the x's over. If you have x on both sides of the equal sign, you want to subtract or add those before you start dealing with the 3's. So we're going to subtract x from both sides first. And what will happen is they'll cancel out on the right side and the left side. So like before, if the x's cancel out on both sides completely and you don't have any x's left, you have a special case. Now you still have an equation and you still need to write everything that's remaining on both sides of that equal sign and finish it. So without x, we have 3 equals 3. There's no x, so this is a special case. We just have to decide, is it no solution or all numbers? And to do that, you look and you determine if this statement is true or not. Well, 3 does equal 3, so it is true, which means the answer is an infinite number of solutions. And we'll show you some other ways to abbreviate this. Sometimes instead of the word infinite, we'll use the infinity symbol. And it means the same thing, but there are some other words we can use for this. But this is what happens. X cancels out, and you're left with a true statement with no x's. So again, here's some alternate words that mean the same thing as any number. So an alternate name for infinite number of solutions, this is the symbol right here for all reals. It's like an R, it's like a double R. Sometimes because of it's hard to find that keyboard shortcut, sometimes if you're on the computer, it'll just show a normal R, and that means the same thing. A couple other names for an infinite number of solution are either all real numbers or just all reals for short. That means the same thing. Sometimes we'll just say any number. It means any number could be plugged in for x and it would work. A little bit more rare, but sometimes you'll see the phrase the identity set. The identity means any number, or this basically means the same thing. The answer is anything from negative infinity to positive infinity is what that's showing. These two aren't used quite as often as the other ones, but you will start seeing those on occasion. Okay, so let's do some examples of some that aren't quite as obvious or as simple to see if it's no solution or all reals, and not all the ones we do will be a special case. All right, so we'll just start solving these equations. Here's my equation. I'm going to start out by simplifying the right side, which means I need to distribute this negative 8, which will give me negative 8m. A negative times essentially a negative is a positive 16. And then I have m's on both sides, so I'm going to deal with that first. It's very important that you get in the habit of doing that first. And what happens is they're going to cancel out on both sides when I add 8m to both sides. So on the left side, I still have 9. And on the right side, I still have 16. My m's canceled out, so I have a special case. I look at it, determine if it's true or false. Well, 9 does not equal 16, so this is a false statement. When it's false, we say the answer is no solution. I'll use the symbol this time. You can always write out the words no solution too. So let's do another example. This one's a little bit longer, but we can do that. If you're more comfortable seeing addition instead of subtraction, remember keep, change, change, or add the opposite when you see subtraction. It'll help you remember that that's a negative 3 right here that we need to distribute. So we distribute before we combine like terms. So we're not going to do anything with the 2x. I'm going to have a negative 3x and a negative 15, negative 3 times 5. On the right side, I'm not going to do anything. There's nothing to simplify. On the left side, I still can combine like terms. I'm going to combine the x's. Positive 2, negative 3 is negative 1x. And remember, I said deal with the x's first. Once you're done simplifying, don't add 15 to both sides first. You have x's on both sides, move them over to the same side. You can add 1x or you can subtract 4x. I'm going to add 1x to both sides. And that's going to cancel out here. I still have negative 15 equals, always continue to write your equations. Negative 15 plus 5x. 1x plus 4x is 5x. And then I continue to solve, just like a normal two-step. My x's did not cancel out, so I do not have a special case. I'm going to keep my 5x. As long as I have x's in the answer, I'm not done. I have to figure out what x is, unless the x's cancel out. So here I have one last step, and that's to divide by 5. 0 divided by 5 is 0. X equals 0. 0 is a solution. It's not one of those special cases. When the numbers cancel out like they did with the 15s, that means your answer might be 0, but as long as you have x still in your equation, you have to get a solution. You have to keep going until you've isolated x completely. Okay, 2 more quick problems. All right, we're going to start off by distributing on the right side here. I'm going to distribute that 2 and get 2x minus 6. I can combine like terms here on the right side. I have a positive 1 and a negative 6. So that's going to be negative 5 plus 2x. Okay, now I'm going to deal with the x's. I have x's on both sides. So you can either add 3x or subtract 2x from both sides. I'm going to add 3x to both sides. Cancels out on the left, and I still have 7. Still have negative 5, but now on the right I have 5x. And I keep solving like normal. So my x's didn't cancel out, so again, I don't have a special case here. Divide by 5. Now, remember, but that doesn't mean it's no solution. On the right side I have x, and on the left side I have 12 divided by 5, or just 12 over 5. Just because it's a fraction doesn't make it any less of a solution. We still have x's. We can figure out what x represents. So that one does have a solution. It's 12 over 5, or 2 2/5. Okay, one last one. Again, I'll start off by distributing on the right side. 8 times r minus 8 times 5. Now, r's on both sides, nothing else to simplify, so I'm going to subtract 8r from both sides. Remember that minus sign stays with the 40. So it's a negative 40 because the r's have canceled out here. The r's also canceled out over here. So they canceled out on both sides. I don't have r anymore. That means I do have a special case. It's going to either be no solution or all numbers. To determine which one, I look at this equation and determine is it true or not. Well, negative 40 does equal negative 40, so it's true, which means my answer is all real numbers, or an infinite number of solutions. Any way you want to say it, any number, or you could use the symbol for all reals, like that. And that's how you determine if it's all reals or no solution. So that's an introduction to doing special cases with equations where there's no solution or there's an infinite number of solutions.